Today we're going to be talking about limiting reagents. So let's start with something that's a little bit familiar. You may remember from our last lesson we talked about those mole-to-mole conversions using just this basic example of making a grilled cheese sandwich. So based on that, if we have 2 slices of bread and then 1 slice of cheese, you get 1 grilled cheese sandwich. That's pretty straightforward. We can write it out just like we would a chemical equation. So let's see what that looks like with limiting reagents. So if we have this example right here, we have these 6 slices of bread, we have these 5 slices of cheese. We want to know how many grilled cheese sandwiches we can make. So everyone has probably made a grilled cheese sandwich before. The first thing you want to make sure you can do, you need 2 slices of bread for each sandwich. So you can have 2, 2, and 2. So according to the bread, we can make 3 sandwiches. We only need 1 slice of cheese per sandwich, so based on that, we can make 1, 2, 3, 4, 5 sandwiches. So the bread is telling us we can make 3 grilled cheese sandwiches, and the cheese is telling us we can make 5. This is something you've probably come across when trying to cook or work in the kitchen, doing things like that. But what we need to know is how many can we make? Well, based on the bread alone, we can only get a maximum of 3 sandwiches out of this. It doesn't matter that we have extra cheese slices, we just won't end up using them. So that tells us that this bread is our limiting reagent. The limiting reagent is the first reactant that is used up in a reaction. So whenever that limiting reagent is used up, no more product can be made, so that reaction stops. So there's another term we need to talk about, and that is excess reagent. And the excess reagent is just whatever is left over because the limiting reagent is all used up. That reaction no longer continues, so there's excess of some sort of reagent. In this case, our cheese is in excess, while our bread was our limiting reagent. So let's look at an actual example from chemistry. So we are asking, what is the greatest amount of NH3 in moles that can be made if we have 3.2 moles of N2 and 5.4 moles of H2? What is our limiting reagent? What is the excess reagent? And how many moles of that excess reagent is left over? So once that reaction that has to stop, how much do we have left? So here is the equation we were given. We have 1 mole of N2 plus 3 moles of H2 gives you 2 moles of NH3. So let's plug in some numbers. If we had that 3.2 moles of N2 that they told us we were given, we would need 9.6 moles of H2 in order to complete that reaction. Where did I find that? This right here. So 3 moles of N2. We know that from the original equation, for every 1 mole of N2, we need 3 moles of H2. So cross out those moles of N2, and you are left with 9.6 moles of H2. So very straightforward. You do the same thing to solve for NH3 to figure out how much you'd be able to make, and it was 6.4. But let's take a look at this. We were told that we were given 5.4 moles of H2. Which means this 9.6 moles of H2, we just don't have that amount. So let's plug it in the other way. If we plug in our 5.4 moles of H2, we do the same thing we did before, 5.4 moles of H2, and we know we need 3 moles of H2 for every 1 mole of N2. We're told that we have 1.8 moles of N2 that we need to use. So again, plug this in, and that's totally fine. We have that amount, because we were actually told we have 3.2 N2. So we do our same equation to find NH3. How much can we make? It's this right here. So what does that tell us? That tells us that H2 must be our limiting reagent, because remember, we couldn't make this equation because we just didn't have enough H2 for that. So we had to go with the one that says 5.4 moles of H2. So H2 is our limiting reagent, which means our excess is N2. How do we know that? Right here, if we have our 5.4 moles of H2, we only need to use 1.8 moles of N2, but we were given 3.2 moles. So that tells us we have an excess of N2 that we didn't even use. So how much excess did we have? That 3.2 we were given minus the 1.8 that we end up needing, we have 1.4 moles of N2 left over. So that's what I put for your answer right here. And to answer that first question, what is the greatest amount of NH3 in moles that can be made with that? Obviously, we have to use the equation where we have enough of all of our materials, and we are given 3.6 moles. Again, use that equation right there below. For every 5.4 moles of H2, 2 moles of NH3 for every 3 moles of H2. Obviously, cross out those, and you're left with how many moles of NH3 you've created. So take a second, look at this, work it out. It takes a little bit of time to figure out, but this is a very important concept that you will need to grasp for chemistry.